Alright, welcome back, grade 11s. Today we're going to look at how we use the quadratic formula. We've already seen how we can solve by graphing, but this is time consuming and it can be inaccurate. We've also seen how we can solve by factoring, but factoring will only work if the quadratic is factorable. So we're going to look at a third way that we can solve quadratic equations. And that third way is to use what's called the quadratic formula. So we see the formula written here. It's x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Looks intimidating, but really we're just using the a value of ax squared plus the b value of bx plus that c value. So whatever a and b and c are, we just plug into this formula and we get an answer. And it always works. So in the first example, our a value is 2, our b value is 3, and our c value is negative 9. So we take those values, the a's, b's, and c's, and replace them with 2's, 3's, and negative 9's. So negative b becomes negative 3 plus or minus the square root of 3 squared minus 4 times 2 times negative 9, all divided by 2 times a, or 2 times 2. Negative 3 plus or minus the square root of 3 squared is 9, negative 4 times 2 is negative 8, and negative 8 times negative 9 is positive 72, all divided by 4. 9 and 72, well, that adds to 81. And the square root of 81 we know is 9. So we get negative 3 plus 9, which is 6 over 4, or negative 3 minus 9, which is negative 12 over 4. And each of those reduces so that we get x is equal to 3 over 2, or x is equal to negative 12 over 4, negative 3.
Okay, let's take a look at the second example now, where we have a is equal to 2, b is equal to 3, and c is equal to negative 3. So if we use the formula, let's just scroll down so we can see it. We'll take the opposite of b, so negative 3 plus or minus the square root of b squared minus 4ac. So 3 squared minus 4 times 2 times negative 3. And that's all over 2 times a, which is 2 times 2. The negative 3 stays, plus or minus 3 squared is 9. Negative 4 times 2 is negative 8, times negative 3 is negative 20, positive 24 over 4. So that leaves us negative 3 plus or minus 9 plus 24 is 33 over 4. And then we can't really do anything with that root of 33. We can't break it down at all. So we just plug it into our calculator and we get two values. We get negative 3 plus root 33 over 4, which is equal to 0.686. And we get negative 3 minus root 33 over 4, which is equal to negative 2.186. Alright, and this is our third example. So here we've got y is equal to 2x squared plus 3x plus 5. Our a value is 2, our b value is 3, our c value is 5. Again, if we plug that into our formula, we've got x is equal to the opposite of b, you can see that just up here, the opposite of b, which is negative 3, lots of negative 3's here, plus or minus the square root of b squared, so 3 squared, minus 4 times 2 times 5 over 2 times a, so 2 times 2. That means x is equal to negative 3 plus or minus the square root of 9 minus, this time, 40 over 4. When we go 9 minus 40, we get x is equal to negative 3 plus or minus the square root of negative 31. And right there is where we find out that there's no solution. It's not possible to take the square root of a negative number. So as soon as you see that, you're done, right? X has no solution. There is no place that the parabola crosses the x-axis. It's a parabola that opens up. It has a y-intercept of 5. It never dips below the x-axis. So from a graphing perspective, this is probably something that look like that. This one here with our two solutions and a y-intercept of negative 3, probably intercepted here, crossed at negative 2 point something, crossed at 0.6 something, so it probably looked like this. And this one at 3 over 2, so 1.5 and negative 3, a y-intercept of negative 9. Let's say this is negative 9, and it crossed at 1.5 and negative 3. Probably something that looked like that, roughly. That should be on the axis right there. All right, so there's our third example. And then next, we'll look at what we can do to simplify some radicals. So let's take a bit of time here, not to do this example 4. We'll get to that in a minute, maybe in class. But I want to look at simplifying radicals. Something that we've done in grade 10, and we build on and need in this section. So something basic. Let's say that we start with the square root of 4. We should all know that that's equal to 2. We should also know that if we have something like the square root of 8, that can be written as two radicals. Ideally, a perfect square first, like 4, or 9, or 16, 25, 36, 49, 64, 81. Remember, those are all perfect squares. 2 times 2, 3 times 3, 4 times 4, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, etc. So if it's possible, I take a radical like square root of 8, and I rewrite it as a perfect square, square root of 4, times the square root of 2. And we already know that the square root of 4 is equal to 2, so that becomes 2 root 2 in simplest mixed radical form. Smurf. If I take something like root 50, I look for the biggest perfect square that goes into 50, which is 25, and I get root 25. I write that perfect square first, times the square root of 2. We know the square root of 25 is 5, so we get 5 root 2 out of that. If I had something like root 27, root 27, that would be like saying root 9 times root 3. Square root of 9 is 3, and that would give me 3 root 3. So let's see what happens if we go to solve something like, let's go solve something like y is equal to 2x squared minus 6x plus 3. Remember to make a list of your a value, your b value, and your c value, and then just plug that into the formula. We get x is equal to negative b. So the opposite of b, the opposite of negative 6 is 6, plus or minus the square root of negative 6 squared minus 4 times the a value, which is 2, times the c value, which is 3. And that's all divided by 2 times the a value, which is 2. So if we clean that up, we get 6 plus or minus the square root of 36 minus 24 over 4. That means x is equal to 6 plus or minus the square root of 12 over 4. And this is where this idea of simplifying a radical or putting putting it in simplest mixed radical form comes in, because I can take root 12 and I can simplify that. So if we continue that over here, we get x is equal to 6 plus or minus the perfect square that goes into root 12 is root 4. And it's root 4 times root 3 that gives me root 12 all over 4. So x is equal to 6 plus or minus the square root of 4 is 2. So we get 2 root 3. Always take the square root of the perfect square, not of the 3. And that divides by 4. Now, you'll notice that this and this and this, all of those are divisible by 2. So I can actually clean this up a little bit more and get x is equal to 3 plus or minus 2 divided by 2 is 1. So I'll just go 1 root 3. And 4 divided by 2 is 2. Where did the 3 come from, you say? Well, that was 6 divided by 2. This 1, 2 divided by 2. This 2, 4 divided by 2. And the radical never changed. So our exact answer is 3 plus or minus root 3 over 2.